Welcome back. Now, things are looking pretty good so far. We have the ability to pick up a weapon. Now, we did go through all that trouble to get other animations into Unreal Engine from Mixamo and retargeted to Echo Skeleton. And as soon as we pick up a weapon, we'd like to switch to a different idle animation that looks like she's holding a weapon, as right now the weapon is attached to her hand and it does look pretty good, but upon close inspection, you can kind of tell that she's not really holding the sword. It's just attached to the hand. Now, we do have this really nice idle animation, and we put our retargeted animations here in an animations folder, and we have this standing idle retargeted. And this is very clearly a pose where the character is holding the sword. It would be great if we can use that. But the thing is, if we just use that for our idle, then it's not really going to look right when she's not holding the weapon. So we have a catch-22 here. We can use one idle or the other, but a single idle pose is not great for both situations. Now, I'd like to see what things look like with our standing idle retargeted. So if I go to Blueprint's Characters and open my character's animation blueprint, I can go into the idle state and look for my retargeted animation, standing idle retargeted, and I can use this instead of the idle state. And now if I press play, she looks like she's holding a weapon, but she's not, so that's not great, but it does look better when we pick up the sword, so this is awesome. So the thing is, we want to be able to switch those idle poses, which means our animation blueprint needs to know if we're holding a weapon. Now, when we start running, yes, the hand is still open, and even though it's a little harder to see, she's not really holding that either. So we'd like to get more running animations where the character is actually holding a weapon, and we'll get to that. But the first step is to let our animation blueprint know whether or not we're holding a weapon. And that way our animation blueprint will know whether to switch between those poses or not. So we need some sort of variable to know whether or not the character is holding a weapon. In other words, we need to know the character's state. So we are going to open up our Visual Studio project and add a variable to our character class so we can know if we have a weapon or not. So I'm going to go into /character.h and add a variable. Now, I'd actually like to use an enum for this variable. And an enum doesn't exist for our character's state, such as unequipped or equipping a weapon, and so on. We need to actually create an enum for that. Now, in regular C++, to create an enum, we would simply declare a new enum type, and we can do it up here, just outside of our /character declaration. And in regular C++, we would say enum, followed by the name of the enum, such as character state. And then we'd have some curly braces for a body, and we'd add some enum constants, such as unequipped. And we'd add a comma, and we'd have another enum constant, such as equipped one-handed weapon, and perhaps equipped two-handed weapon. So this is how we would create a regular enum in C++. And because this is defined here in the character's header file, we can use this type here. So I could go into, say, my private section and make a new enum of this type. It's called character state, so we'd say character state state, for example, and we could even initialize it to a value, as this enum can take on the value of any of its enum constants, such as unequipped. So this is how you would intuitively do this in regular C++. And later on, we could check state and see if it's equal to unequipped or equipped one-handed weapon or whatever, and use that somehow to drive our logic in the game, right? Now, Unreal Engine has a number of conventions and additional features, so when we make enums in Unreal Engine, we do it a little bit differently. So let's back up a little bit. Let's rewind all the way back up to our character state enum. And the first thing I'm going to point out to you is that enums in Unreal Engine are prefixed with an E, and that way we can always know that this particular type is an enum type. So that's one thing. That's the Unreal Engine convention, is that we put an E before the Enum name. Now, another thing that's pretty common in Unreal Engine is that we use scoped enums. This means that instead of just enum followed by the enum name, we type enum class. Enum class makes what's called a scoped enum. And that means later on, if we need to use one of these types, we have to fully qualify that enum constant with the enum's type name. Let me show you an example. If we created this variable of our new enum type, eCharacterState, and called it state, for example, if we wanted to set it to a value, we would say eCharacterState with the scope resolution operator, and then we would select the state. So anytime we use an enum constant of this type, we fully qualify it. Now, this is a sort of safeguard that protects us from having multiple enums that may have the same enum constants. We might have an eCharacterState and we might have an eNemyState, and they might both have unequipped as one of their states. But if they're scoped enums, then we don't have to worry about confusing the two. We fully qualify these constants with the enum class name, so there's no ambiguity here. We know which one we're talking about. We're talking about the enum constant unequipped and the eCharacterState enum. So that's the benefit of having a scoped enum, and it's generally recommended that we use these scoped enums. Now, enums are really just a list of named integer constants. Really, each of these are associated with an integer value. By default, the first enum constant is equal to the integer 0. And the next one is 1, the next one is 2, and so on. Now, in enums, you could go and override that. You could say that unequipped equals 3 and equipped one-hand weapon equals 7 if you really wanted those enum constants to have specific enum values. But we typically don't use enums for their numerical values. We use them to identify things like states, such as our character state is unequipped, or equipping a one-hand weapon, and so on. This is just a lot more descriptive than simply making an integer like int character state equals 1 and just trying to remember that if this integer is equal to 1, that means we're holding a weapon. And if it's equal to 2, we're holding a two-handed weapon, and so on. That would be a naive approach, and enums are a more elegant way to do that. Now, of course, in Unreal Engine, we make use of Unreal Engine's int32 type because that is more cross-platform. It ensures that our integers are 32 bits no matter what our platform is, but that's beside the point. The point is, if we want to keep track of states, an enum is a good way to do it, and a scoped enum, using the class keyword, is an even better way to do it. So that's typically what we're going to do. And we have this eCharacterState called state, but state is not exactly the most descriptive name, right? But that's one of the other benefits of having the E prefix. We can call this enum character state. And because we called our enum eCharacterState, then the identifier character state is free to use. So we don't have to call it simply state. We can call it something more descriptive. So we have this enum, right? And we'd like to use it in our game. So that's great. Now let's talk a little bit more about conventions. I mentioned that our enums are going to be prefixed with E, so that makes sense. But in addition to that, to really avoid ambiguity, it's nice if all of our enums have unique constants as well. Now we may have another enum with an unequipped state, but if we prefix our enum constants as well with something, then we can make them a little bit more unique. And in Unreal Engine, the convention is to take a sort of abbreviation of the type. Our enum type is eCharacterState. So an abbreviation would be the capital letters ECS. And if we prefix our enum constants with ECS underscore, then we can take a look at this enum constant and think ECS, eCharacterState. So that's another Unreal Engine convention that you'll often see. So we're going to do that for our enums too. We're going to follow this good practice. We're going to call these ECS underscore and give them their names. So ECS underscore equipped one-handed weapon, equipped two-handed weapon, and so on. And now this is looking a bit more like something you'd see in Unreal Engine's codebase. Now, I mentioned that these Enum constants are integers, and we can even hover over them to see what their numerical values are, 0, 1, and 2. But unless we plan on having 1,000 or 1,000,000 Enum constants in E character state, these don't need to be the largest Enums around. They can actually be quite small. In fact, we can specify that these Enum constants should be a small integer, like an 8-bit integer. And Unreal Engine has uint8, just like the int32, but the uint8 has u in it because it's unsigned. You can't have a negative uint8. You only get positive values with uint8. And in addition, it's an 8-bit integer. So we have an 8-bit unsigned integer designated for the integer type for each of these constants. And now we have a little bit more of an optimized enum. Now this enum is a raw C++ enum. If we wanted to, say, access our variable E character state called character state from within blueprints, for example, we couldn't do that. We couldn't use this as a type in blueprints as is. But Unreal Engine has a way to allow this to be a type usable in blueprints. And to do that, we use an Unreal Engine specific macro. It's uenum. Now, just adding uenum means that this type can be exposed to the reflection system. And there's a specifier for uenum that allows us to use this as a type in blueprints. And that specifier is blueprint type. Now, as soon as we give this a blueprint type, this becomes a type that can be used in blueprints. Pretty simple. And when we expose things to blueprints, we typically like to make them a little bit more user-friendly, right? In blueprints, it's not going to be very user-friendly to see this ECS underscore in front of the name. Typically, names in blueprints look a little prettier. And we can do that with our enum constants as well. We can give them display names so that once we use this enum in blueprints, we can decide here what we see for these enum constant names. In order to do that, we use another macro. We add a space right after our enum constant, and the macro we use is umeta. We're going to give this some metadata, and the specifier for umeta that we're after is display name equals, followed by a string literal. So we can give this constant the display name unequipped. And now in blueprints, if we use this type, then this enum constant will just be unequipped and not ECS unequipped. So it'll be a little more user-friendly. I'm going to copy that umeta macro and paste it just after our second enum constant, equipped one-handed weapon. And we can give this one a better display name. I'm going to call it equipped one-handed weapon. And I could hyphen this, it doesn't matter. And finally, I'd like to give the third enum constant its own umeta and change it to say equipped two-handed weapon. Now, if we use this enum in blueprints, these are the constants that we'll see instead of these ones, which are a little bit more programmery, right? So now we have a new enum for the character state. And the thing is, we want this character state to reflect our character's actual state. And notice we get the red squiggles because we renamed this. It's no longer unequipped, but I can hit backspace and delete that and hit that second colon on the double colons and choose from the drop down here. And I'm going to choose ECS unequipped, as our character is going to have its state set to unequipped by default. We don't start off with a weapon. But as soon as we pick up a weapon, we should set the character's state to something like equipped or equipped one-handed weapon or something like that. So we need to do that. Now, if we look at our E key pressed, we're taking a look at our overlapping item and casting it to overlapping weapon. And if it succeeds, we call equip. Now, our weapons don't really have a one-handed status or a two-handed status. They're just weapons. So really, we're going to ignore the fact that our enum has a two-handed weapon equipped state. But for now, we're going to keep things simple and just set our character state to equipped one-handed weapon. So at this point, we know we're equipping a weapon, so we can take our character state variable and set it to character state equipped one-handed weapon. So as soon as we've equipped a weapon, our character state changes. So our character state is reflecting whether or not we have a weapon. Now this is all great, but the whole point of this state is so that our animation blueprint knows whether we have a weapon or not, and then it can go and change the pose. And we're changing this in C++, but we do have the ability for our Enum instance to know if we have a weapon or not. You see, we created our Enum instance class. It's called /Enum instance. And in public, we have under characters our /Enum instance header file with our variables that we're updating every frame. So it would be great if we can use that enum type here. Now we know that it's generally a good idea to keep the number of included header files in other header files to a minimum. And if we wanted to add a variable to the Enum instance of the type character state, like this, and call it, say, character state, then if I go ahead and compile this, then we'll get a compilation error. And this is with my Unreal Editor closed, by the way, as I'm using live coding. So I closed the editor and compiled from here, and we get an error. We don't succeed in compiling. And we see that the error is right here. It's telling us it's in /Enum instance, line 32, and right here's my line 32. My character state enum, it's causing an error. It says unknown override specifier, so it doesn't recognize this type, even though IntelliSense is smart enough to know and not give us red squiggles. So this is because our enum is defined in /character.h, which means if we want /enum instance to know about that type, we'd have to come up to the top and do an include here, and we'd have to include /character.h in order to get rid of our compilation error, and then we could compile successfully. In fact, I can go ahead and compile, and I'll see that it compiles just fine. So we succeeded. But as we know, it's a good idea to not include header files in other header files if we can help it. And just a side note, the reason I put this above the last include is because the generated.h file has to be the last header included. Just a reminder there. But either way, this isn't the best practice, including the whole /character here, as we don't need the /character, we just need that enum type. But we know a way to get around this. We've done it already. We can create our own header file and define the enum there. So we can do that. So I'd like to make a new header file. I'm going to right-click on my characters folder in the public section, go to Add and select New Item and choose Header File. So we can make a header and define the enum there. I'm going to call this character types. But remember, if we do this, it's going to try to actually stick it in the intermediate folder, which is auto-generated, and when we compile, our new header will be gone. So we need to click Browse and go into the correct folder. So I'm going to go all the way out to go to source /public. I'm going to make this public so we can access it from public files like our headers. And I'll go into characters and I'll put it here. So we have our character types header. We're putting it in the characters folder. In the public characters folder, we're going to click Add. And now we have this character types. And instead of defining it in /character, we can define it now in our character types header file. So I'm going to highlight this enum, the whole thing, Control X to cut it, and I'm going to move it into character types. So now it's in this header file. And don't worry about the red squiggles. This is not a compilation error. IntelliSense will eventually catch up. But now this enum is defined in this header file, which means /character can't use character state unless we include that character types header. So we're going to include that up here at the top. Include character types.h. Now, this is not as bad as including a big, huge header file. We're just including this little header file here. It just has an enum in it. And that means we can go back to /enum instance and include that header file here. So just above the .generated, I'm going to include character types.h, and now we have access to that type and we can use it. So this is great. So now our Enum instance has a character state, and our /character also has a character state, and this is the one we're updating. We want to actually update our Enum instance so that it reflects the character's character state. And we can do that in /enum instance.cpp, where we're setting our variables. So here in native update animation, every frame we're setting ground speed, we're setting is falling, and we can also set our character state. So we can say character state equals, and we can get that from /character. So /character, which is a variable that exists here, and we can get our character state. Now, there is a problem with this. This is inaccessible. It's a private variable. Now, that means we can either make it public or we can make a public getter for it. So I'm going to make a public getter down here next to our public setter for overlapping item. And just like set overlapping item, we can make this force inline, as it's a simple getter. And it's going to return the type character state. And we'll call this get character state. And our body can simply be return character state. Now with getter functions, these only need to return a value. We don't need this function to change anything on this class. And a general const correct move here would be to make this a const function, which just means put const right after the parentheses there. That means this function cannot change anything on this class, including the character state variable, which it doesn't need to do. It just needs to return character state. So that's a good policy there. And now that we have a public getter for character state, we can go back to /enum instance and we can call the public getter, get character state. And now every single frame, our Enum instance will have its character state variable updated with the correct value. And we can do things like expose this to blueprints and access it in our animation blueprint. And that's what we're going to do in the next video. We'll expose this to blueprints and actually put this character state enum variable to use. Great job. I'll see you soon.